Hello, my name is Eirik Engen. I work at Rheinmetall Norway in Tønsberg, and I have been studying the online master in industrial IT and automation, and have now finalized my master thesis, which was the line of sight stabilization using direct drive actuators in a gyro stabilized sensor system. Such a sensor system you can see on the image here, where you have two types of cameras, a thermal camera and a daylight camera. The line of sight gyro stabilization is a system where we define the line of sight as the vector from a camera sensor that points to an object of interest in space. The line of sight stabilization is then the control function that maintains this line of sight towards this object of interest. This is done by driving the pan and tilt unit with the sensors and stabilizes the disturbance coming from, for example, a vehicle while you're driving. The sensor system consists of a pan and tilt unit which has two drives, one for azimuth and one for elevation. Here in this master thesis we focused on the elevation axis, and a prototype was developed using an EtherCAT test environment, as you see on the upper right side. The goal was to compare the frequency response for the direct drive system, which is actually a pure electrical motor without any gearbox, versus a harmonic drive gearbox system consisting of a gearbox. We developed a LQ optimal controller used as a stabilization controller to obtain the optimal performance of the stabilization. We then compared the performance of the stabilization of the direct drive versus the harmonic drive by implementing the LQG controller on the prototype, and we conducted frequency response measurements and stabilization performance tests. Before this, to develop the controller, we had to have a model which we could use. First, we developed a mathematical model using Newton's second law of rotation. Then we compared this model to measured data from the system, and we got really good fit results. The linear quadratic controller was implemented on the prototype together with a Kalman filter estimating the states. The performance of the stabilization was quite good, and you can see the effect of the stabilization on the bottom video, where we first have a non-stabilized system with the motion as shown on the upper videos, and it looks like the video is standing still. This means that it is stabilized. So the results from the thesis was quite positive. Thank you.